Today we will conduct the tensile test experiment. All of you are aware that tensile test plays an important role in understanding the behavior of material in the tensile load. Okay, and the material is subjected to axial, tensile or pulling load. Okay, the material will have to respond to that kind of load. How it is going to respond? This is going to be tested using an important machine called universal testing machine. This is widely used in industries and also in educational institutions to understand the behavior of materials under tensile load. This machine is made by a company called Crystal Element, and the capacity of the machine, that is the maximum load you can use during the experiment in this machine, is around 40 tons. So approximately 400 kilonewtons. If you look at the principle of the working of the machine, you have two units, very major units. This is called a loading unit. This is called, this is the loading unit. This is the measuring unit, right? So in the measuring unit, in the loading unit, you are going to fix the tensile specimen. This specimen is also called dog bone specimen. You are going to fix this specimen in the upper jaw and the lower jaw, okay, using the vertical columns. These columns is been machined with power screws to lift the jaws and try to fix the specimen. Once the specimen is fixed rigidly, okay, we are going to mount the strain gauge device on the machine. So in order to measure the strain induced, the strain gauge is here. I think you can have a look into it. This is the strain gauge which you are going to fix to the specimen, and this is going to measure the strain in the axial direction. Epsilon, this is called delta L by L. This strain is measured using this particular extensometer. This is also called extensometer. Once you measure this strain, you have to also apply the load in order to find the stresses induced in the material. The loading is done with the help of an hydraulic power pack, which is built into the system, which consists of a motor and a the hydraulic piston cylinder element with an hydraulic fluid. Now you can look into the operation now. He is going to lift the jaw, the lower jaw, with the help of a power screw column. Once he lifts the jaw and secures the workpiece, he is going to fix the extensometer. Then he will apply the load, okay, increment the load. You are going to find the strains. Then you will note down this load. Then initially you have to note down the specimen dimensions. Specimen dimensions. That is the diameter and gauge length of the specimen. You can have a look. Slowly. Now you can have a look into it. He is going to fix this specimen. Now you can have a look into the method of fixing the strain gauge. It is also called extensometer, to measure the uniaxial strain. That is the point where the extensometer is fixed. That is the gauge length, we call it as. You have noted down the gauge length initially, okay, and also the diameter initially before you fix the specimen there using vernier, okay. Care has to be taken during the mounting of the extensometer on the specimen. They are very sensitive devices to measure the strain induced in the material. Now the next step is you are going to set the reading for the application of load. Set for 200 kilonewtons. Now we have to apply the hydraulic force to measure the strain and stresses induced in the material. Then I will look into it. Now, once the measurement starts, you have to note down the reading. You have to note down delta D1 and D2. Take the average. The least count of this instrument is 0.001 mm. Right? You need to also take that into account and find the 5 strain induced. 2 element 2. Ten. 4 1. 15. 5 1. 20. 5 2. 25. 6 3. 30. 4 6. 35. 5 7. 40. 8 6. 45. 8 11. And 50. 9 11. Now guys, you have found the strain induced and applied load. Now you plot this stress strain curve. Within elastic limit, you are going to get the Young's modulus. If you measure the slope of the graph, the Young's modulus of the given material is obtained. Now, what you need to know is continue loading, okay, till you get the fracture. This, since it is a ductile material, you will have a kind of fracture called conform fracture because it is going to exhibit a plastic deformation. Now you have gone up to elastic limit. Continue loading, you will get the yield point. Then, if you continue loading, you will get the ultimate, and finally it eventually leads to a fracture. Okay, so you have to measure the fracture strength as well as you need to measure the percentage elongation in the material, that is the amount of ductility of the material, and during the elongation there is a reduction in the cross-sectional area. This is naturally, obviously you can observe this. So that has to be found using the percentage reduction in the area of the specimen. At the end of the experiment you have to find the final diameter, that's called final diameter, to measure the various quantities. That concludes the tensile experiment. Apart from tensile experiment, you can conduct bending test, shear test and compression test using this universal testing machine by appropriate specimens and appropriate arrangements. The entire machine works on the hydraulic principle. It is an electro-hydraulic machine, right?